Good afternoon and a very warm welcome. It is our great pleasure to welcome Dr. Prashant Anand, Assistant Professor, Department of Architecture and Regional Planning, Indian Institute of Technology, to the Faculty Development Program on Smart Building Design, DCT for Net Zero. And Dr. Anand will be delivering a session on the highly relevant topic, that is passive cooling strategy for sustainable buildings and cities. In this session, we look forward to gaining the valuable insights into the climate responsive design approach that minimize energy demand through natural lighting, thermal landscape integration, and other passive cooling techniques. So welcome Subham sir to briefly introduce the expert to the participants. Over to Subham sir.
Thank you so much, Ravish sir. And good afternoon, everyone. It is an honor to introduce our esteemed speaker, Dr. Prashant Anand, Assistant Professor in the Department of Architecture and Regional Planning at the Indian Institute of Technology, Kharagpur. Dr. Prashant holds a PhD from National University of Singapore and MTech in Building Technology and Construction Management from IIT Madras, and a Bachelor's in Architecture from NIT Patna. His research focuses on building science, energy efficiency, and indoor air quality, with an emphasis on sustainable and resilient urban development. He is also an editor for the journal Energy and Buildings and an active member of leading professional bodies like ASHRAE and ISIAQ, contributing both to academic discourse and industry practice. In today's session, he will deliver a talk on passive cooling strategies for buildings and cities, where he will share evidence-based approach to enhance thermal comfort and reduce energy use in built environment, and essential theme in the context of climate responsive urban design. Please join me welcoming Dr. Prashant Anand, and over to you, sir.
And over to you, sir.
Thank you.
Thank you,
Subham. Both of the Subham. Yeah. So, am I audible?
Dr. Prashant Anand for and look forward to an engaging and helpful session. And over to you, Prashant sir.
Yeah, thank you so much, Subham sir. Thank you so much, Subham. Yeah. So the topic is passive cooling strategies for sustainable building. And first of all, I am really thankful to both the Subham and BK Das sir and all the faculty who all are involved in this particular topic and this particular program, because this is very relevant considering this all the kind of the climate change related implications what is happening. In title, I missed to write cities here, so forgive me for that, but I'm going to discuss a little bit about cities also, from building to cities level things, right? So with me, Mr. Nilabro Mandal is here, who is a PhD scholar at the Department of Architecture and Regional Planning, and he is working in the area of urban climate modeling, all those things, building to urban level assessment. So the presentation we're having two parts. The first part I will discuss about a little bit of theory, and then he will discuss about a tool, how to use that particular tool, City Energy Analyst, or which particular tool you are going to discuss now? City Energy Analyst. So he will discuss about City Energy Analyst, how you can use that tool to do assessment of the built environment. Okay. So to start with presentation, let me see if my slide is moving. Is my slide moving?
Yes, sir.
Hello. Okay.
Yes, sir. Your
so the content
of
the theory part is the first. The content of the theory part is the first. Briefly, I will discuss about the introduction of this particular topic. Recently, from the Department of Architecture and Regional Planning, NIT Kharagpur, we have published a book for Ministry of Forest, Environment and Climate Change, and the topic of that book is passive cooling strategies for sustainable building. And most of the content in this presentation is more or less related to this particular book. Okay, so I will briefly introduce that. Then I will discuss about why we study building material sustainability, why it is important for urban sustainability. Then I will discuss about there are growing concern about the renewable energy integration to building. What are the potential? What are the pros? What are the cons? All those things I will discuss, and then I will discuss about the urban sustainability, like CTS scale mitigation and adaptation strategy, whatever we are thinking of. What are the implications of those? And then some conclusion and future research directions. So to start with, the first question that we must understand, and there should be answer for this, why it is important to study building material, why it is important to study building sustainability. Actually means so many courses is running in this country and around the world, and what is the purpose behind running all these courses and all these learnings. So the reason behind this is, if you will look at this particular timeline prepared by one of the authors who cited here, this is the history of human living, and you will see here in around 2000 25,000 BC, we were living in painted cave, and slowly we moved from painted cave to bone hut, mud brick, and the final ultimate goal in this all development from that time to this time is we are looking for what is called self-sufficient building. So the end goal is here that whatever is the building we are constructing and the built environment we are developing, that should be the self-sufficient. So why this self-sufficiency is important? That means we have to look back into the concept of sustainability. What is the definition of sustainability? That means that whatever resource we are using, we have to use in such a manner that there should not be a case in the future generation scenario like there is no non-availability of that resources. So we have to be responsible enough in using whatever resource we are using. So self-sufficiency means there is no external source is required to run that particular building. But is that even possible from that time to this time? Whatever advancement happened, is that even possible? More and more we are moving towards development. More we are threat to sustainability. So the ideal sustainability is, means it's a very crude way to say this. Ideal sustainability is like we have to return back to the history of human living in 25,000 BC, and the age where we were living in the stone cave, those kind of thing. Because that was the true sustainability. There was no resources required to develop a building and to run that building. So the self-sustainability can be divided into means why this resource is required to construct that building, to operate that building, and to maintain that building, right? So these are the three areas where energy and resources is required. So is it possible to do something in these three areas to minimize the burden on the environment, and the building can be a self-sufficient building? So this is the overall concept. So now, second thing is, to address this issue, we have to understand that what is the requirement of building. Right? Why even we require a building? Why do we want to live inside a building? Because outdoor condition is very harsh. It is not possible that the presentation I am giving to you, I will sit outside in rain, or I will sit outside in sunny day, and I may not be able to see screen also, right? Because of the brightness there may not allow me to see the screen. So for that, a conducive environment is required where we can do our daily activities. Daily activities means reading, writing, sleeping, all those things in a more comfortable way. So for that, protection is required. Protection is required from what? Weather, wildlife, biological contaminants, chemical contaminants. Within that, weather is one of the extreme and key things, because the weather is bringing solar radiation, heat, and moisture. And these are the key three things which building is able to control and give us an indoor environment which is more conducive for our daily activities. Now we have to understand why these three key things, especially this weather-related, solar radiation, heat, and moisture, is impacting one of the key requirement of the building is that cooling requirement, right? Okay, so for that we have to understand the thermal properties of building. So why these thermal properties of building is required? Because we have to maintain thermal comfort inside. Then we have to understand what is thermal comfort, because if a building is thermally comfortable, then only we will be thermally comfortable, right? So what is thermal comfort of human? As per ASRE or any other guidelines, the comfort, this thermal comfort is a state of mind. The state of mind which express satisfaction with the thermal environment. That means currently, suppose my mind is saying that, okay, I'm comfortable now with the temperature, whatever is around my body. That means I'm more or less at the condition of the comfort. If it will say neutral, like means I'm not able to feel warm, I'm not able to feel cold, I think somewhat in middle I'm here. That means a state is neutral. Okay, so same way, this state of mind vary from one person to other person. So for example, how many of you participants are here? Can I ask a simple question? How many of you are feeling cool? Can anyone answer? Okay, no one is there, no problem. Okay, so if you will take this kind of survey, then what you will get to know that majority of them will not go in the same direction. Some of you may say it's slightly warm, some of you may say it's neutral, some of you may say it's very warm, based on the condition where you are sitting, right? And based on the other contributing factors like your clothing level, your metabolic rate, other contributing factors. Okay, so then we have to understand how this thermal comfort is getting maintained actually. Suppose we are a person who is healthy, means we are not doing anything, we are just sitting on table or chair and normal way, then the body will try to maintain a skill temperature around 32 to 34 degrees Celsius. But at the same time, our core body temperature will be around 37 degrees Celsius. When temperature is dropping, what is happening? That our body is trying to minimize heat loss by reducing blood circulation to extremes, right? And this is leading to cold kind of discomfort. But what is happening at the high temperature? Our body is trying to actively dissipate heat through sweating or increase blood circulation. This is to prevent overheating. So our body is trying to maintain heat through this mechanism. Other than that, the way we are inhaling, exhaling here, the way the radiation is happening around the surface of our body, the way the air movement is around happening around the body, is trying to maintain the outdoor skin temperature. This is how our body is trying to maintain heat balance. The same way building is also trying to maintain heat balance. It is through same conduction, convection, and radiation. The amount of heat we are getting through conduction, the amount of heat we are getting through radiation, the amount of heat exchange, whatever is happening through convection, through that the building is also trying to balance heat. And whatever is the indoor environment, that temperature, that finally human is trying to balance through their inhalation, exhalation, and body, right? But suppose this whole mechanism is still not able to maintain the desired temperature what human is required, then again go to previous slide. At higher temperature he may feel overheating, at the lower temperature he may feel cool. Not the entire body part, at a certain body part. If our heart will continuously feel cool, then it may be very dangerous for us, right? So how these things were taken care earlier, in the earlier days? There was no mechanical system, there was no HVAC, all those things. Earlier time we were more dependent on the conventional way of cooling, right? Passive strategies, use of natural material, use of local material. So these materials, because these are extracted from the local side, this is more adaptable to the local environment, right? It was able to maintain the comfort inside that particular building, right, in a more efficient manner. Okay, and even the human who is from that particular area is more acclimatized to that particular outdoor extremes. Okay, but when we move from the conventional practice to the more modern practices, when we change the use of local material and when we move toward the different materials which is having high thermal mass, okay, use of concrete and all those things, then the maintaining same level of heat balance inside a building as per the requirement of human is become difficult, right? So why this become difficult? Because we move post-industrialization time, we move towards more mechanical systems and those things, and the material also the more modern material we started using. Okay, so in this graph we can see that what are the factors which is actually contributing to the thermal comfort inside a space, or the say the energy consumption inside a space, because the energy consumption is mainly due to the cooling requirement of the building, other than the plug load and light load, the majority part of the cooling, and that cooling can be controlled through different ways and depends on the various things related to the building, like what kind of envelope building having, what kind of mechanical electrical system building having, what kind of indoor design it having, what kind of operation and management, how you are maintaining your building when you're switching AC, when you're switching off AC, switching on AC, all those things, what is the climate outdoor, and also the behavior, how we are interacting with the system. All these factors is controlling the kind of comfort and energy requirement of the building. Okay, so far we have understand that when we move from the pre-industrialization time to post-industrialization time, the more requirement of energy started happening. Okay, and more development will happen, and more requirement will increase. That cannot be avoided. Okay, so this is one of the data which says that space cooling energy will be more than double by 2050 if no action taken immediately. Okay, this is as per the IEA report. Another data is from India. Here you can see that in 2018 it has been reported by IEA that per person energy consumption in India is only 69 kilowatt hour per person per year. Okay, at the same time USA, see what difference here is. In India we are consuming just 69, in USA they are consuming around 1878. So it's a huge difference, right? Okay, but still they are also saying about energy efficiency, or they are also taking actions for this, all the climate change implication, whatever is happening. Okay. The another report, which is by our own MOFCC, Government of India, what it is saying, by 2030 and 50, the kind of urbanization is happening, the kind of development is happening. India, Nigeria, and China, they themselves is going to consume 35% of the gross world energy demand, right? So if we will not act now, if we will not learn from the mistake what the all other developed nation did at their earlier stages, we are also going to be a big energy means consumer in the coming years. Okay. So what are the implications? So see what is the global implications here. So greenhouse gas emission is related to global warming, and because of that, the more frequent extreme events are happening related to heat waves and urban heat island events, etc. Okay, and in terms of the what are the our contribution, we are just 17.78% of world population, and our contribution out of the 1.5 degrees Celsius of the global warming is just 0.0 degrees Celsius at the current stage as per this report. However, in future, what is going to happen that you can guess from the previous slide, the way we are going to consume energy, because the more and more means earlier means when I was kid, there was no AC in my house, right? Hello. Okay, so when I was kid, that time we were not using any split AC in my home, right?
Sorry,
and now I am using a split AC in my home. The same way, the more and more the urbanization is going to happen, the more and more means we are going to purchase, the purchasing power is going to increase, the more and more residential sector is also going to consume a lot of energy, which we are currently not consuming. Okay, so what we can do, these are all the research statements so far we have discussed. What can be done? What can be done? Okay, so there are mainly three steps which is required. The first is the way we were earlier promoting passive design. Now also we have to promote passive design, because that is the first thing what we can do, right? The second thing is behavioral change. If we are not ready to change our behavior, then there is going to be a rebound effect. Like earlier, when we were using a normal mobile, for one charge it was running for 4 or 5 days. But how much we were using it? These days, more advanced mobile came with a touch screen and so many features, but every day we have to charge it. Okay, so why? Because the consumption is increasing. Okay, so if the consumption will increase, more or less the same amount of energy we are going to consume, does not matter how energy efficient it is, or even you may be going to consume more. Okay, third is we have to use more and more energy efficient equipment. Now come to one by one, this how we can reduce energy consumption using passive interventions. Okay, so for this, as I discussed in the previous slide itself, it's all started after the industrial revolution, when we moved from the conventional practice to more advanced practices of the construction and all those things. Okay, so in 1919, the first rating system came into picture by Breen from UK, and from that time onwards, lot of rating system came, which started promoting the sustainability, sustainable practice, green buildings, and all those things. In India, the first rating system came in year 2001, most probably by IGBC India. Then in 2007, this Griha came. Okay, and from that time to this time, continuously a lot of revision and enhancement is happening in that guidebook. Okay, but more or less, all these guidebooks are discussing all these rating systems. Sorry for saying it. All these rating systems are discussing more or less same things. Like the target is to minimize environmental impact, energy consumption, water consumption, solid waste management should happen. We have to consume resource in a more responsible manner. But the target is fixed, that we have to minimize carbon footprint without compromising health, comfort, and well-being of the occupant, whoever is living inside that space. So it should not be a case that we want to save energy and we are living in discomfort. So outdoor is suppose 45 degrees Celsius temperature and we are not using AC, we are living in discomfort. That is also not desirable. So we have to look for a solution that if outdoor is very high temperature, then how to minimize for outdoor temperature? We are not able to minimize outdoor temperature. Then how to minimize the temperature, whatever is there is coming outside to inside. Then the third thing is like in what way, what equipment we can use that the comfort is maintained, at the same time the overall carbon footprint is getting minimized. So this is the overall strategy that is discussed in all these rating systems. So now come to the passive cooling strategies, which is the key, the first thing. These techniques can be divided into three parts. The first is heat protection, second is heat modulation, and third is heat dissipation. What is heat protection is like whatever is heat outside, our buildings should get protected from that heat. Okay, so that is the first step. So we have to use the building thermal mass, we have to use the nearby landscape, we have to use the window wall ratio, we have to use the glazing, we have to use the shading in such a manner the amount of heat gain from outside to inside should be the bare minimum. The target is near zero, but if there will be near zero, then the light will not come. So we have to maintain daylight. At the same time, we have to minimize heat gain. So that way we have to optimize, and we have to maintain the lowest possible heat inside the building through building design. Okay, and material selection. The second thing is, okay, we tried our best, but still there is a certain amount of heat that is coming from outside to inside. Then how to modulate that? So then the concept comes the thermal mass. If you have a high thermal mass, if you have the high thickness of wall, what is going to happen is the heat will take time to come from outside to inside. Okay, so during sun hours, like from morning 7 when sunrise is happening, or 6 a.m. when sunrise is happening, from that time to evening 6 p.m. when sunset is happening, till that time building is absorbing heat, it is continuously absorbing, but till time it will reach to indoor surface of that particular facade, till that time evening will happen and it will start irradiating back. So that kind of thickness we have to decide based on that particular local climate. Okay, but it also depends on the climate, where you need thermal mass, where you don't need thermal mass. Second is the free cooling constant. Then third is coming to heat dissipation, that we tried our best for heat protection, we tried our best for heat modulation, but still we are not able to maintain comfort inside. Then the third thing is the heat dissipation, like the convective cooling, the evaporative cooling, radiative cooling, all this cooling mechanism. Okay. So these are some of the pictures, just an illustration of the how building orientation is helping, how landscape is helping in minimizing heat gain, and how the different shading elements are helping for the first part, heat protection. This is for the heat modulation, how this thermal mass thinks and is able to minimize heat gain from outside to inside, or modulate heat gain from outside to inside. Okay, like the use of thermal mass and Trombe wall, all those things. Okay. You may have studied this during undergrad architecture, but I'm just repeating because when Lavra will discuss about all those tools and techniques where this concept is going to be used, because the foundation is required to run any tool, because there is no magic in running any tool. Okay. So then finally it is about the heat modulation, how to modulate heat, like we can use low SSGC, low U value material, all those things, high reflective surface, all those things. Okay. And one of these are some of the findings from our own study. And what we have identified, something like if you will use cool coating on the roof surface, then the near surface temperature of the air will reduce by up to 4.5 degrees Celsius. That was tested in Riyadh. But the same thing when we tested in Kolkata, the temperature drop was happening around just 2.3 degrees Celsius. So you can see that there is a difference, because the same material in different climate is performing different. And in the second one, in case of Kolkata, it is not performing well because of the high humid condition. But in case of Riyadh, where it is a hot desert climate, it is performing very well, because the infrared radiation is getting easily back to the environment. In this case, it is getting trapped in because of the high humidity. Okay, so these are some of the heat modulation concepts. Now, in case of heat, the dissipation, like the natural ventilation, water features. So I will not go into detail of all this. This is a very basic. And as I discussed, like all these techniques depends on climate also. For different climate, same concept cannot be used. So first you have to understand climate, and in that climate, what kind of technique we use to minimize heat gain inside the building. Okay. So now come to renewable energy integration. So you have designed a building, that is passive design, it is perfect, the best possible design you have met. But even the best possible design may not be able to provide comfort. You have designed best, you have selected material best, everything is perfect there. But still there will be energy requirement for run that building. Because outdoor is very extreme, outdoor is 45 degrees Celsius or something like that, even higher. So indoor temperature will be always higher, right? And that temperature may not be in the comfort range of a person. So in that case, AC or some kind of cooling mechanism is required. Okay? And for that, energy is required. So if that energy is coming from non-renewable sources, that is again harming sustainability. So we have to look for solution like how to compensate those energy requirements through renewable way. So what we have done in this IIT Kharagpur campus, this is a study from one of my PhD scholar, Kritika Panikan, and one of the authors is Prof. Abraham George. So what we did here, entire campus, we have collected energy data, and we have simulated every building. And what simulation we did, like if we will install solar panel over rooftop of all residential building and for different typologies, and if we will install that roof, those panel in facade also, In that case, what is the potential to converting this entire campus into a net zero energy campus? And the findings are very promising. Like means the energy requirement inside campus is not that high. Means we are the way means the energy consumption is happening inside residential means part of the campus is very more or less is very less. And the same whatever is the requirement, supposed to be 5.5 kilowatt hour per square meter per is the requirement of a different typology, then we are able to achieve more or less net zero just by installing facade and rooftop solar PV. Okay, and this is the data what you can see here. Then what she is trying to develop a rating system using that, because there is no rating system for residential building based on these parameters. Okay, so this was related to building. Now come to the urban. Okay, so you have designed a building very well. You have installed solar panel also or any other renewable source so that the energy requirement of that building is meeting. But since outdoor temperature is so high, right, we are not able to maintain indoor temperature as per human comfort. Even there is a renewable energy integrated to that building, that is also sometimes not able to meet the requirement inside, because this was for the low-rise residential building. What will happen in case of the high-rise and densely populated residential building? Because this is high-rise, densely populated, so rooftop area is less compared to the total floor area. So the energy requirement is only dependent on the area where the direct solar radiation is coming or the diffuse is also coming, will give, but not that high. So in that case, converting that building into zero energy building and running that building purely on the renewable may not be possible. So there will be always a requirement of grid related energy. And when grid related energy is coming, then there will be always question about the sustainability and greenhouse gas emission, all those things, right? So in that case, we have to minimize outdoor temperature also. And for that, from building to we have to move to urban level study, like how to mitigate the UHI outside, right? So for that, there is an emerging concept of urban building energy model, right? So from building a scale to urban scale, energy exchange, thermal exchange, all those things you have to model properly. And then the feedback of how building is giving feedback to urban environment or the climate, how urban environment and climate is giving feedback to the localized area, and from that to building, and from that to human. That complete cycle of things should be properly modeled. Then only it is possible to mitigate the heat outside. So one of my scholar, as I said, Neil Abro, is working in this particular area, and he is going to share, we'll discuss about that particular tool, which is freely available, Building Energy Analyst. Okay. So this is the model. What can be minimized outside to minimize heat gain inside? So like I discussed earlier, right? So heat is coming inside a building through conduction, convection, and radiation. And the key thing what we can minimize outside is the heat, whatever is coming through the radiation inside. So the roof surface albedo is one of the key things. Okay, surrounding surface albedo, interbuilding heat exchange, road albedo, setting effect, wind flow disruption, anthropogenic heat, all these things you have to model at building to urban levels. Then only means it is possible to look for the solution to mitigate the heat related implications. So this is one of the mathematical model that I will not go into detail. Okay. So far we have discussed about slowly we came from the human to building to urban and sustainability, all those things we have discussed. Now everything is looking like a very good picture so far, right? And I have discussed about solar panel also, like so if you use solar panel, then it's a very good solution. It's a renewable energy solution and will make building zero energy building. Even it is getting promoted also, right? Through different mechanism. Okay, but we also have to look into like blindly we should not use a solution without knowing if we will use that in a larger scale, then what implication is going to happen. Like I earlier discussed about the use of mobile, things that I want, right? Okay, so what will happen in case of solar panel? If we will use lot of renewable like solar panel, then what is going to happen? So this is one of the study that we recently published, led by one of the professors from Calcutta University, Prof. Ansar Khan, and the main mentor is from University of Sydney, Professor Max and Tamois, and we all are one of the co-authors. So in this particular study, the key identification is like if you use rooftop solar panel, there is a chance that there will be daytime warming and nighttime cooling. So what is this daytime warming? What is the nighttime cooling is happening? Because the surface of the solar panel having very low albedo. And why low albedo is there? Because the purpose of solar panel itself is to trap heat, because that heat is finally converted into the usable energy, right? but it is not able to convert everything into the usable energy, right? Only the 20% of the heat, whatever it is absorbing, is finally converted to the energy. Then what is happening to the 80% of the heat? Because earlier for the rooftop, what we are preferring, that it should have low albedo, it should have high albedo so that it should reflect back heat to the environment rather than absorbing. But in case of solar PV, what is happening? It is absorbing it, right? So it is trapping heat. So that 88% heat is finally in the surrounding area of this PP, right? And because of that, daytime heating is happening. Up to 1.5 degrees Celsius temperature increase is happening. So this is to model this, WRF, BM, and BP configuration is a multi-layer urban canopy model integrated with BM model has been used. And when Nilab will discuss, he will roughly discuss about all these modeling techniques, right? But the modeling technique, what they have used, not only in this paper, in the many other papers, is about this NOAA LSM and BEP and building energy models. So it's a kind of integrated model from urban to building to human level, all those data. Okay. So this is the finding of a study that I already discussed. Like in Calcutta, we have tested like if the entire Calcutta rooftop will be converted into solar PV. If every rooftop will have solar PV, then there will be a warming up to 1.5 degrees Celsius daytime, and there will be a potential lower nighttime temperature up to 0.6 degrees Celsius. The same thing we have tested for Austin, Brussels, Athens, and Sydney, and more or less similar findings were coming there also. Right. So the conclusion of this presentation is like there is a possibility to minimize heat gain from outside to inside, but there is a chance of rebounding effect, right? So although BIPV and rooftop photovoltaic solar panel can help in making building zero energy building, and relatively setting can reduce the load and temperature inside a building, the same full coverage of rooftop based solar panel entire city level can create a negative implication also, like daytime warming and nighttime, right? And also this material, whatever we have discussed so far, like this cool coatings and super cool material, their performance also varies from climate to climate. In hot and dry climate, it may be performing really good, but in humid climate, the performance may not be that great. But still, the performance is like it is able to reduce the temperature. Okay. So that's all from my side. If you want to go into a little bit more detail about whatever so far I have discussed, this is the ministry published book. You can scan this code and go through that book, and you can also mail me, and I'm very much I will be happy to answer you whatever question you all have. Okay, best of my ability. So now I am handing over to Nilab in continuation of this presentation. He will go through the city energy analyst and will discuss about how this concept can be implemented in that tool for the modeling of a building. Over to you, Nilab. I'm just stopping.
Hello, am I audible?
Yeah, yes, sir. Audible, sir.
Oh, okay. So thank you, Prof. Anand, for giving us this wonderful introduction and theoretical background. So now, as Prof. Anand was telling, I will try to discuss little bit foundational understanding in the urban building energy modeling, and also a tool demonstration, particularly its name is City Energy Analyst, and how we can use it. It is an open source tool, so whoever present in this discussion can access this tool, can use it in their own time to understand the urban this building energy modeling area. So to start with, the discussion flow will be first a basic understanding is why the UBEM or the urban building energy modeling is needed. Okay, I'm not sharing this.
Share your screen.
Okay, so So as I was telling, the discussion will be majorly focused on the urban building energy modeling and how we can use it using an open source tool called the City Energy Analysis. The background of the urban building energy modeling is somehow majorly discussed by Prof. Anand, but I will just somehow little bit go into the much more detail into the framework of the urban building energy modeling so that it can help us to understand the working flow of the software itself. Before going to the urban building energy modeling, I would like to introduce or I would like to start the discussion first with the building level energy modeling. And as we all are majorly here architects or science of the urban science area, I think many of you know that whenever we are doing some kind of design, we kind of doing some kind of suggestion for the system itself or what energy demand will be the building having. Simulation based building energy modeling is one of the most relevant platform for us to estimate what the building has in its requirement, including the building construction, building materiality, building operational details, and how the human will also interact within the building. Now, whenever we are discussing about the building energy modeling, the extent or the system boundary around the building is majorly considered within just the building, and the neighborhood effect, as Prof. Anand was also telling, is not majorly considered initially when we as an architect or maybe any maybe some facilitator who is doing some kind of assessment, they just consider only that building scale impact. When this building scale system boundary may be just immediate surrounding of the building, the input or the control majorly in that modeling platform is the construction details we are putting, the building operational schedule we are giving, that how the building will work, and also the spatial layout or what will be the spaces inside the building so that we can know the other things, maybe how people will interact within that space, what will be the equipment load in that space, what will be the cooling load in that space, so that the estimation. Other than those details of the spaces and the operational schedules, obviously the occupancy behavior, how occupant itself or themselves are using those equipments within the building, how many hours, how many days they are using it, for how many period they are being present in that space, all those are taken into the consideration. And another input consideration is the climate. When those input parameters are considered within the building energy modeling framework, the major outputs that we are expecting is the cooling energy demand of the building, the indoor comfort preferences. Obviously, it can act as an input parameter also, but sometimes we get if we are giving certain kind of baseline scenarios or certain kind of inputs, what can be the overall performances. And also the immediate outdoor building temperature, surface temperature, those can be the allied output of the building energy model. Now, there are a lot of tools available there. As you can see in the left hand side, the Open Studio or Energy Plus, those are the open source tool, as a building scientist we use. And the right hand side, Design Builder, IES, Climate Studio, or the Rhino. Those are majorly either students or as a researcher we can access through licenses, or those needed to be brought, or just that can be afforded through licenses. Those things. Now, it is noted that when we are coming out of the building boundary of the immediate boundary effect and we are starting to consider the surrounding, this picture I think Prof. Anand has already discussed. So other than building itself, there are a lot of surrounding impacts we need to take under consideration. And the research says that whenever we are considering the neighborhood impacts, they are being reported much variation into the building cooling load or whatever the calculations we are doing. These are the two of the major examples that if we are not considering the neighborhood impact, there may be 10 to 200% variation in the single building cooling demand itself if the neighborhood impact is not well considered. Now, going to the next, this picture is again was discussed by Prof. Anand. So in the urban building energy modeling framework, we try to consider the building itself and all the surrounding impact, maybe the shading impact, what is happening, the surrounding road albedo, the reflectance from the surrounding surfaces, and whatever the other anthropogenic heat emission the surrounding buildings is doing to the immediate environment, so that the local temperature is also rising than the global temperature. So all these things are need to be considered within that framework. For that, this urban building energy modeling concept came, and basically there are many models for this urban building energy understanding. We'll discuss, or what we're discussing is majorly the physics-based model, where the basic procedure of the heat mass flow balance is considered within a physical modeling framework, but it is much more little bit integrated than the normal building energy modeling framework. Now, if we see the application of the urban building energy modeling, it has two kind of application majorly, or the I would say the extent of it. First is either in one building is situated within an urban setting, and we are concerned about that single building itself and what are the surrounding, including climate, greenery, the built morphology or the unbuilt morphologies are putting impact on that building. Or maybe we are selecting a whole bunch of building in a city setting, and we're trying to understand what are the overall impact either from the neighborhood scale, or the scale can go beyond the neighborhood to the maybe certain locality, or maybe whole city level, or whole certain regional level, how all this building together are getting impacted or also impacting the environment. So this whole UM framework can be used in a very, I can say, in a flexible method, where from certain one building to a n number of building you can consider, and you can do the estimations or the simulations. Now, whoever can, this is just to discuss who can be the benefactors or who can take help of this UVM framework. Majorly, whenever we are discussing or we are doing certain kind of analysis in an urban scale, the decisions either are taken on the national level or maybe in urban local body level. Whenever those decisions are being taken, maybe those decisions are to be implemented in certain, I would say, in a certain scheduled manner, or maybe in certain spatial extent. Now, let us, we have been given in certain urban patch, and then the ULBs decided, okay, let's divide the urban patch within certain sectors, and then within certain sector, we are considering that is our system boundary, and we are then implementing our UM. Majorly, whenever UM is implemented in those decision-making phases, either it is to plan certain kind of energy infrastructure, or to plan certain kind of district cooling planning, maybe within an institute or some other places, or maybe neighborhood scale retrofitting strategies. Maybe whole area is dilapidated and we need a revamp of the whole infrastructure there. The major usage of this UVM or the users can be obviously as we are the students and the researchers can take, or the urban building or the climate researchers can also use it. Architect or the urban planners can use it, as well as the policymakers can also use these tools to take certain kind of decisions. Now, these are some paper from MIT published who introduced this field majorly to the world, maybe the UVM concept. So these are the certain examples where the previous discussions I was talking about, when urban local bodies or whoever the policymakers are taking certain kind of decisions, maybe these are the one of the examples where the urban planning, maybe how the urban developmental controls can be planned using the UBIM. This is one of the example where you are looking about what are the controllable affairs, what are the ratios within the, or the aspect ratios within the building patches planning, and if those are been happening, then what will be the neighborhood energy load altogether. Another application can be, other than energy, how this kind of urban level planning or usage of these buildings altogether in a whole urban setting can be used for carbon footprint measurements. Another kind of application of this kind of UBM platform is the city level or regional level renewable energy integration. As Sir was also discussing about the city level PV we are applying, but Sir was discussing about what are the implications on the climate, and the climate, how is it impacting the PV and how it is happening. But here, before those assessment of detailed PV impact on the climate, we need to understand if we are installing certain kind of photovoltaic system in a whole urban area, what will be the overall energy generation potential of that whole area, right? So this UVM platform can also be used for those. Now, I'm slowly moving to the demonstration of the UVM tool. There are many famous tools for this kind of urban scale energy modeling, and majority of the tools are either cloud supported or it can be run by certain kind of large laboratories who can support certain kind of large data sets handling. You can understand these are the large scale simulation based tool, so may not be every system can support this certain kind of running. So one of the major famous tool, or that was much more made very famous in usage of UVM, is CTBES, that is developed in LPNL. The website link, you can go there. So it is the platform where, as of now, they have by default designed some kind of US highly developed cities, and there they have certain kind of mapping. But if as an we from our end, we are if we would approach them or CTPS to do those kind of planning, then we need to take a certain kind of license, we need to model it. So there are various processes, and that process is not that much streamlined. So we'll not discuss this tool particularly. Another tool is developed by MIT itself. It's called UVM-IO. It is also being used in various applications, and it is majorly offline tool. It is not online. But here the modeling approaches, here the handling of the tool is not that straightforward, and also running for these tools, you need a certain kind of other modeling platform, maybe Rhino 3D or whatever else, which needs certain kind of licensing. So we'll not also discuss this tool, but this is just to let you know there are certain lot of tools which ever been used around the world. Now coming to the third tool, it's called the City Energy Analyst, which will majorly focus in our demonstration. It is developed by and APFL in a joint endeavor, and it is an open source tool. You can download it, and the accuracy of the tool is obviously not that equivalent that of the previous maybe CTBES, because that CTBES runs completely on the energy plus that whole building heat mass transfer model, simple heat mass transfer model. But the City Energy Analyst resistance capacitor model, where the accuracy is not that much in a single building level, but in a whole urban scale level or maybe neighborhood level, the accuracy is comparable. And this can be run on your own system. The scale will matter in the computation. If your computation extent in terms of scale is little bit limited, maybe 50 to 100 building, it may take maybe half an hour or 15 minutes. But if you are trying to simulate a whole city, then you need to dedicate a certain amount of time, because you can understand obviously though the resistance capacitor model is a little bit less complex and take less time to compute, but you need to dedicate a certain amount of time for that. So now next on, I will move to the demonstration. So I will close my presentation and I will directly go to the demonstration part. Okay. Before going to the demonstration, I'll just discuss certain terminologies that we will note in that tool so that you have a basic understanding of that. Previously, I was discussing about the construction details, the building operations, spatial layouts, as well as the occupancy behavior. These whole input control, these key performance indices or the key parameters are together called in those platform are building archetype details. Okay. So whenever we'll run through the tool, we'll see that the building archetype details are being mentioned, so that you don't have any confusion in understanding. I'm just mentioning it here. Now, the major system workflow of the tool is like this is the system boundary, where there is a single building or a lot of building you are simulating, where the surrounding effects within the scale of maybe 0.5 to 5 kilometer maybe or 0.5 kilometer is within the consideration. So this is not building scale, this is a neighborhood scale consideration. Now here the input parameters is obviously the building archetype, as I said, and the climate data file we are giving, and the output again that cooling needs for the 1 to nth number of building that we are simulating, those we are getting, and other outdoor and the indoor comfort conditions, those we are also getting. Now in that simulation framework, other than extent of space, there is a concept of extent of time also, for how much time we are simulating. Maybe for diagonal differences, maybe for certain day or night time, we're just simulating to check the what will be the peak demands, or maybe we are simulating for a whole bunch of period. So it can be the long-term analysis or the short-term analysis also. Whenever we are showing the demonstration, it will be majorly based on the climate data file. It will be based on the 30-year energy simulation maybe, but it will not take that much time. Okay, now moving to the demonstration of the tool. Okay, I will just and I will go to the directly tool and how we can use the tool. Just give me a minute. Okay, I think my screen is visible. Uh, and I'm audible also. Right. No. Yeah. Okay. So this is the if you just want to download the city energy analyst. Yeah. So you just write city energy analyst and you go to their website. And you go to the CA for Windows. Is my Video lagging? I think so, right? Can anybody confirm? Sunai there, I guess. Okay.
You're audible, sir.
Yeah. No, I can't. Huh. My screen is shared, right? Okay. So you go to the city energy analyst. And from here, you can download the city energy analyst. I'm not doing the download stage, but you can do it is an open source download, so you can download it easily. Now, I'll try to open the city energy analyst software.
Can we use this for in iPad, sir?
iPad, I think there is for a Mac version, so you need to check it. But I think you can use majorly. Okay. So whenever you are clicking on the city energy analyst dashboard, this kind of new project and the open project area, you will get it. So this is the folder location where you will start with your project. Either you can click on the new project. If you click on the new project, you will get in certain kind of project root. I have specified one folder, but it's up to you what specification you want to give. Let project name, I am providing certain demo 02, and then clicking on the create. Now, when I'm clicking on the create, you will be landing up on this kind of platform where you can click on the create new scenario, and when you will click on the create new scenario, you will be directed to a dialog box, this kind of thing. So this is a basic project template. Whenever we start AutoCAD or Revit, we have been asked about to set the template and all those details. This is certain kind of that, where you can import the basic geometries, or you can select the whichever area you want to select. Now, this city energy analyst has within its consideration certain kind of open source geospatial datasets which can construct 3D geometries where the datasets are available. If I zoom it on the IIT KGP, there the datasets of the buildings are not that available. So I will try to zoom it on maybe NIT Patna or just Patna. and you can see I am being able to open a certain kind of Google map. Let to do an energy modeling for this campus. So what we can do, first we set a scenario name, maybe demo 02. No. Dataset path, this is a default folder directory where certain kind of building properties details are being already given or default downloaded within the system itself. You can edit it, but I'm not going to that detail. But whenever you can go through the City Energy Analyst website, there is a certain manual you can download and you can go through what the CH means, what the SG means, and what the directory contains. As of now, I'm keeping it CH. Now, other than importing direct OpenStreetMap data, you can also import your own geometry files through these import input files. But as of now, as we are having certain kind of geometric data, we are not exploring that option. But you have also that option. If you are having certain kind of own geometry, you can also import that within this platform. Now, here coming to the location part. This is the lat long. Maybe you can specify lat long where the areas or the buildings you want to map. This is the area where you can just write, maybe it can search. Now here is an option in that right hand side, which is called talking about drawing. Now you select there, and using this tool, you can select the areas which you want to consider for energy modeling or the analysis. You need to complete that polygon. So what this software will do, it will extract all the geometries within the coverage of this shaded region, and also it will import the possible neighborhood regions. Okay. Now it is also giving me the what amount of area I have taken into the consideration is 0.20 kilometers square. And then I am clicking on the button create. Upon clicking on the button create, it will create the environment for doing the analysis or the simulation. And you will land up on this kind of page where you can see using the mouse middle button, you can do and pan or moving. You can use the right hand side button to the geometry or to see the 3D model. This left hand side panel is for doing the analysis part, all those things. And this bottom side panel is for understanding the data that been assigned to these certain geometries. Now, by default, you can see all the building height. If you click on any of the geometry and go to the architecture part, you can see that there is not much architectural detail assigned to each of the geometries. Okay. So whenever you are opening this file, we follow certain steps. You just first go to the database editor. Here you first check what are the building details being provided here and what are the standards they are following. So as the tool is developed by ETA Zurich and the EPFL, some of the databases are following the ISO standards, and as per their own comfort, they have provided certain kind of default datasets. But all those Excels, this City Energy Analyst is accessing through certain kind of external directories, and those directories are default made by them. And if you want, you can change those directories following a certain file type. Let it is in .txt format, so you can do the edit in .txt format and resave it. You can open those files here. There will be no issues. So you can see first, as I was talking about, you will note the details of the archetype. So here are the construction standard and the user type details. User type details are the majorly what are the space usage schedules, maybe yearly, monthly, and day hour basis, how people are using the space, and also the what kind of comfort preferences, what kind of the internal loads are majorly been given. This there is a default setting already been done, but whenever you are doing the certain kind of modeling, you need to standardize these as per your own standards and the local usages, right? And these are the various other spaces being provided. So as per the, maybe if I'm considering restaurant, those are some kind of default values being provided. Key set point temperature maybe to the 21 and all those things. So you can change those numbers as per your own comfort by clicking on here. Particularly that model calibration part where you do those things. Then coming to the assemblies. Assembly means particularly the building building envelope details, building structural details, and the specific geometric or the material properties you are assigning to each of the building materials, maybe, or the building components, maybe the windows, roofs, walls, floors. Let you are clicking on the wall. So what will be the U value? What will be the albedo value? What will be the emissivity value of the wall paints or the materials? Everything is been taken from certain kind of standard. You can see what are the reference file. But if you want, you can add certain kind of row. You can see there is an option. And also you can add your own U value, A value, E value following your own local usages. Same goes for the floor, same goes for the shading. There are certain kind of standard shading provisions provided, but again, you can change those values as per your own model preferences. This is a component part where other than energy, those other modeling approaches you can do, and I'm not going to discuss this part. You can explore it your own time. Now, again, I am going to the project, and this logo is to navigate through the project. Whenever we are opening a project, our first work is to assign the building archetypes, means building geometric properties, building user settings, and all those things. As of now, only geometric properties is been or has been imported, but we need to assign the spatial usage pattern and all those things, right? And let you want to change the geometric properties of a building also. If you select and maybe this building you want to change, you can select here, and here you can see there is an option to change the height. Maybe I want the height to be 20, and if you click OK, you can see that building height got changed here. Okay, like this. If you want to change a whole bunch of building, you can filter on selection. You can select that building, or you can filter out the selection, and all the buildings that are being mapped here, those geometric details are being provided here. So if you want, just click on any of the tab and you can change the floor areas, what are the average heights of the building, and all other details. Now, other than these geometric properties, I need to assign what are the usage pattern, what are the door window details, and all those things. So for that, here the first step is go to the data management and go to the archetype mapper. So what it does, it maps the properties from the initial tabs I was showing in that Excel file, and okay, concept changes, and you will land up on this kind of dialog box. Here, what mapping will be done? The comfort preferences, the architectural details, the air conditioning preferences, the internal load preferences, and the normal schedules. Here in the advanced setting option, you can either select specific buildings you want to consider, or by default, all the buildings that you have imported will be considered. And now you will click on run script. Whenever you will click on run script, here you can see and bottom this kind of option, and here a code is running. So it majorly a Python code runs within itself, and the city energy analyst has within an itself certain kind of small conda platform where its own codes runs, and you can see here the job first one, the archetype mapping is completed. Okay. Now, what does it mean? If you go to now to the typology, architectural, internal loads, indoor comfort, you can see the data from the initial tab I was showing that had been mapped for the buildings. If you want, you can change, you can select the specific building, you can change the data here, and after changing, you need to save the change. Okay. Now, post this archetype mapping has been done, you need to import the weather data file. Now, by default, they have certain kind of weather data files being provided, New York, Singapore, Zurich, and many other things. But particularly, we are interested on that Patna weather data file as of now. So you need to download your own EPW 30-year weather file. So for that, I have already specified the A1 weather, maybe Patna weather I didn't found. So Darbhanga weather EPW file I found in the net, and I am importing it. Now, how to access a basic weather files from the net? What you can do, you can go to the EPW map ladybug tool, this link. What it does, it has a 30-year average, a basic weather file around the world. So maybe for Patna or Bihar, any area, you select on that data file and you download that. Okay. Now, once those weather file you have downloaded, here in that City Energy Analyst platform itself, you import that weather data file and you run the script. Is my screen freezed, or
Yes, sir.
are you
It's
been able
freezed.
to? Okay. Please save it. Just okay. Stop video submit. I think my screen is visible now, right?
Yes, sir.
So, yeah. So, if I'm clicking on the run script, you can see I have imported the weather data file. And again, this job 3 has been created, weather helper has started. And you can see that whatever the background code is running, you can check there. Maybe sometimes happens if there may be certain kind of issues. So if you want to check the issues also, you can click on the show logs, and whatever the code is running, it will open before you, right? So that you can understand what are the issues the file is facing or in the processing. so that you can take the next decision. As of now, it's all smooth running, so we are not going to the that details. Okay. Now, once the weather data file is done, another three things we need to do. We need to map the surrounding, we need to map the terrain, we need to map the street thing. So let's again go to the surrounding. I am keeping it for the demonstration case, a basic, the default setting what been there. It means key other than our concerned building, to consider the neighborhood buildings, what kind of surrounding buildings we need to map. Maybe we are in a very dense setting. As of now, the area where we are concerned about are not densely surrounded by other high rises, right? But here is the buffer radius till in meters. What other neighborhood buildings you want to import their geometries so that the neighborhood effects, and when the building radiation analysis been done, all those neighborhood effects may be considered or not. For that, these neighborhood buildings are to be imported. Okay. So again, you will run the script and the surrounding helper will run and it will map the surrounding buildings if we are having any. If we are not having any, there will no building come. Otherwise, there will be building in the surrounding it. As of now, within 15 meters, there is no neighborhood buildings, so there is no changes reflected. But let aside, if there be many developments here, and around, then you could see the surrounding buildings have also been imported. Okay. Then again, go to the terrain. Here, the certain kind of grid setting and the elevation details you need to provide. I am keeping it again in a default format and running the script. Okay, it is also done. Then the last one is the street mapping, and you just run the script again. Why these steps are needed? Maybe we are planning certain kind of district cooling strategies. So maybe that infrastructure for the cooling is running along the major transportation roads. So for that, this kind of mapping are needed actually. So these are the allied settings. But for running the whole system, the basic default run you need to do. Okay. Post all these things have been assigned, you can see that red new road lines you can see. Maybe then for the whole campus late, maybe we are planning certain kind of, as I'm not repeating my sentences, but as I'm telling you, maybe certain kind of district cooling systems you are planning, or certain kind of other planning you are doing, or maybe renewable energy control networks, then that can be planned along these networks if it is needed or not. Okay. Then once this all the data has already been mapped, so overall the building archetype data as well as weather, so major input process is done. Now what you need to do, you go to this box again and now go to the demand forecasting, means the major energy demand estimation. So first stage comes, you need to map the building solar radiation that is falling here, so that it will give you several kind of outputs. One, solar radiation is obviously needed to understand the shading effects, the overall solar external gains what you are having, that you can use for the energy input or energy model itself. And also maybe you are planning for PV systems along all the building rooftops. So what will be the renewable energy generation potential? For that, you need to run this building solar radiation analysis. This is a very long process, maybe majorly because this is a hybrid, what I would say, very detailed analysis done. Here is an option called multi-processing. If you are having certain kind of parallel computing scenario, then your process will be maybe from 15 minutes to it will be trickled down to 1 second. But as we are running on simple our own desktop system, we will not have the multi-processing system on. And then these are the settings, these are the basic albedo of the terrain you want to have, and there are certain other advanced settings where the level of details in which grids or in which level of details you want to run the radiation simulation. So as of now, I am keeping it as a default format, and whenever you will explore the software itself, you can understand what are the grid settings means. While grid maybe 200 the wild grid details means if when wall is mapping, there in certain kind of 200 grids. So if you are in final resolution, you can do maybe 1000. But if you again go to the final resolution, the computational time as well as effort both will increase. Right? Now, again, I will click on the run script. I don't know, my network connectivity is not that strong. So maybe while running the script, my screen again get freezed. Let's see. It will take a little bit of time, maybe 5 to 10 minutes, or not that so. Let's see. You can see the whatever the job is happening in that now the code running, everything those maybe command prompts are just getting mentioned here. Writing radiance parameters, running this command, writing that, and all these things. So whenever we are mapping or doing certain kind of the city level or the urban scale assessment or analysis, the computational power or the computational this kind of difficulties is the major reason we search for much more advanced open source or maybe parallel computing based tools, which maybe as a single person may not run in a single system. So we may need certain kind of high computing facilities whenever the extent of analysis or the extent of the calculations are increasing. Majority of these calculations are done. So you can see the writing result to the disk. So in its output folder, I will show where it saves all this data. So the data of the radius analysis are also saved as a separate Excel file for each of the buildings so that you can do the plotting, you can do the extended analysis out of this city energy analyst platform itself. So the radiation run is also completed. Now, other than that, another thing is key building occupancy mapping. We already had certain kind of occupancy schedule and the occupancy usages, but what this mapping does, it maps key, okay, we have certain kind of occupancy usage pattern within that building, but what will be the around the year or maybe as per the weather file data, what is the extent? Maybe for the 2 days we are doing the simulation, or maybe 30 year we are doing the simulation. So for the 30 year, maybe that usage of the occupants within that spaces is populated through this command. Okay, again we'll off the multiprocessing and we'll run the script. Now, before running, one thing I was forgetting. So there are two options. One means in the schedule model, deterministic and stochastic. Deterministic means the specific usage of the space will remain constant, or maybe the space is occupied in certain hour in certain percentage, maybe from morning 9 to 12 if it is an office building, maybe from morning 9 to 5 p.m. It is 0.8 percentage, sorry, maybe 80% of the space is completely filled, right? Maybe when the time is afternoon, then maybe the occupancy share within the space is 20%. So, but stochastic model, what happens? It randomly takes or it uses a certain basic Monte Carlo what I would say, if certain kind of occupant is present there, maybe next person will be present there or not, it will be based on 50-50% chance. So you have that option also to do there. But majorly we'll now stick to the deterministic modeling and we'll run the script. You can see for each of the building, it is populating the operation schedules. So schedule for the building number 1 to now 36, 42, and the job is done. Now, post all these things are done, final part remaining is the building energy demand modeling. Again, we'll off the multiprocessing part. All the buildings are under consideration. And again, this advanced modeling. What kind of output in that final Excel you are expecting is the PV, grid, the energy, and these are the various names of the cooling potential, cooling power, whatever, and the output for the overall energy demand within the system or including the basements. And there are many other parameters. When you go through the maybe the manuals, you can get the what does the MCP WW system means, right? And also some kind of temperature outputs as I was telling. And the resolution you can set either hourly or on monthly format. It's better to have hourly resolution. And all these settings you can change or you can consider as per your requirement. And then you can do run script. This is the final stage for getting the results generated for this task. You can see the building number 8 completed out of 44. So this kind of comments are also being mentioned so that you can understand how much job is done or how much job is done. Here. So till the results is generated. Now once the results are generated, it is saved in an external folder as an output folder, and within that folder there are other several subfolders where the demand, the PV potential, everything is tabulated format. I'll show you that. And also within the City Energy Analyst platform, you have option to explore the result itself. I'll show you that also. But it is always preferred whenever you are as a student, we are exploring the tool. The usage of City Energy Analyst result viewer is better, but as a researcher or the maybe it is when it is an extended application, it's better to go to the detailed Excel file, and from there you can analyze the data in a much more detailed way or your intended way, right? So the job is done, and this is the dashboard for the result, and here you can plot the result. Okay, now you just add plot. Maybe the scenario comparison is not needed, but we just need the energy demand data, and with the energy demand we want the energy induced data. Maybe you just click on the next. Here is the what the project file you are asking about. Obviously the demo 02 Patna, the name we have defined, and all the buildings are to be considered. Or if you want to not consider all the buildings, or for any specific building you can select. As of now, each of the buildings are under select. You'll just click on the OK. So what it will do, it will again running a code and extracting the data from the output folder, and you can see it has done a plotting on itself also. Now if you want to take a broader look in the data, it has plot for the buildings, and you can just use your this cursor and you can zoom in to the building data detail itself. So you can see these are the end use hot water demand and the heating demand, but these are not correct data because the model is not calibrated, right? So it is running as per their own inferences. So we're not going to the accuracy of the results as of now because you need to first calibrate the model as per the need, as I told, and then you can get the accurate data. But this kind of interactive data visualization within the City Energy Analyst platform also you can get. We want to add another plot, and that is the maybe solar potential and the solar radiation plot. Again, you will bring the next. Your normalization not needed. Let gross floor area, time frame monthly or hourly. Okay, maybe yearly you are taking, and you are clicking on OK. So you can see in the bottom half another data being generated. As I was talking about, the climate data file may be considered from 1999 to 2018. So each year, what are the generation potential are being mapped. Maybe for some year the data is not available, so the generation potential is not mapped. And I want to zoom in any of that. So you can go to the detail of the data in certain year and what are the solar radiation generation potential you can do. But this is just for this platform of data visualization. As I said, for basic student level or the master's level, if you're doing certain kind of small project, that's fine. But it's always preferred you go to the actual output directory where the output data are being saved. Okay. So you go there, new volume, maybe I'm going to the area where my data was saved, and maybe demo 2 this was, and the demo 2 Patna, and these are the output file. Now if you go to the folder, you will see demand, occupancy, solar radiation. These folders are there. You go to the demand and you will see for each building the overall Excel file is there. This is for the separate building, the Excel files are also being stored, and this is for the whole building. All the buildings are under consideration in this Excel file. Okay, click on that and you can see here are all the building details, and the building geometry details have been provided, and here along these all the columns, the all other data that's been generated, maybe the cooling potential, the heating potential, the cooling load, heating loads, all those kind of data are being saved here. So if you are doing certain kind of research and other things, you can take this Excel file, you can process those data again in any of the visualization platform, and you can generate your graph, you can do the analysis, you can check in as per your own comfort, you can do all those decisions. So this is a basic workflow in this City Energy Analyst. And now, before conclusion, I think I'll just show another application of this tool. As Sir was initially mentioning, the super cool materials application, right? So how we can use the City Energy Analyst as per our own understanding. Maybe I will go directly to this page. My PPT is visible, right?
Yes.
Okay. So these equations already Sir has discussed, and all those details of the albedo, surface emissivity, all those things you have seen in that City Energy Analyst platform itself. Those values you can set. So what we are doing here now, you just notice on this table. So here we are taking 3 scenarios. First, base case scenario where wall is provided dark paint finishes and the roof is provided with the dark paint and the core performing thermally. So here are the U value, A value, emissivity values, and the reflectivity or the solar absorption coefficient values. Another case we are considering where a little bit of advanced material has been taken, where wall is conventional finishing being provided and the roof is provided with white coating paint, not super cool material. And another case is the conventional finishing wall with a certain kind of specified U value and also roof with super cool coating. So these are the 3 scenarios, and these 3 scenarios are run using City Energy Analyst. Now, this is the case study in a certain Kolkata area where these are the buildings and these are the neighborhood building effects also you need to consider. So again, you download the local climate data file, you give the material input, the building archetype sets, and you run the three scenarios: one base case scenarios, one the intervention case where the normal white roof paint is applied, and another intervention case is when the super cool coating is applied. Okay. Now, post running in the CEA, you will get this kind of plotting where the base case, case 1, case 2, and all the 170 plus buildings data. This is not well readable, but let's zoom in certain kind of buildings. So maybe the red ones are the base cases, and the orange ones are the just white paint added, and the less skin color or maybe that less red one. This is for case 2 where the super cool material applied. Now you can see within the whole building patterns, majority of the building are having majorly when the super cool material is applied, it is having less energy demand also other than the conventional coating. But you can see certain cases where the overall energy demand is also increasing. So if this whole around the building or around the neighborhood impact is not considered, maybe this whole variation within this kind of performances may not also be well captured. If we see around this 170 plus building, the overall performance comparison, a basic box plotting, so it's noted that in the first case, when the normal cool coating is applied, there from the base case energy demand, 1.7% reduction has been done. And when the cool coating is applied, 2.58% reduction has done in the overall energy demand. And I'm just approaching the end. This is the basic resistance capacitor modeling framework of the city energy analyst. I'm not going to the details. This is the paper details. You can go there. This is developed in NIT Zurich, this paper in Applied Energy published. So you can see the software is not that old. It is introduced in 2015, and through the years, within maybe 10 years, it has faced a lot of developments. And now at our end, it is freely available for usage. And if somebody is very much proficient with coding or their own customization, the city energy analyst platform itself can be molded as per our needs also, using their own coding environment, because it is an open source tool. So I'm closing here, sir. So thank you. And again, as if you are having any doubt, you can reach us, or we'll be happy to discuss over mail. Sir, my part I'm done.
Thank you, sir. Now, the participants, if you have any query, you want to discuss anything, ask about the tool, the platform is open for you. You ask the expert directly, or you may write in the chat box.
Sir, which computer language can be used for like customizing this software?
You can use Python.
So is it handy to learn, or tough? Like an expert is required?
I think whenever you are exploring the tool, first before doing the customization, you can first understand what are the provided setting within that platform. And when you download the city energy analyst, you download for another small Conda platform for city energy analyst itself. So there are manual provided in the city energy analyst website also. You can read from there. And I think if you are a little bit proficient with coding, you may take time, but you can also do your own customization with time, right?
Have you done any customization, sir?
Not yet that much.
Okay. No, it didn't require you, or you didn't try it?
As of now, I'm also exploring that tool, so I didn't have that requirement as of now. But if you check in the internet also about this tool, you can get a lot of videos where the customizations are being said about, and it's up to you, like if you want to.
Thank you, sir.
Any other participants? Sir, in your presentation, you already shows that rooftop solar panels, you have done a case study that impact on the thermal performance in the daytime and nighttime. So you can done this study on simulate on in other climate zones. Yeah, only in that specific case area.
For Kolkata, we have simulated and we have tested the same model for different cities around the world, like Austin, Texas, Brussels, Athens, and more or less similar kind of finding was coming from there also. It is warming at the daytime and it is cooling at the night time.
Other climate zone there is a need to study this.
Different climatic zone assessment kind of thing so far we have not done. But within that means cities, if you will see, there are variation in climate, right?
Sir, in the beginning, you have selected some extent around the proposed site. So, what is the maximum extent we can select?
This is related to a tool or theory part.
First part,
What extent? I didn't get your question. Can you please repeat?
no, to get the influence of topography around the site, you have selected like some extent.
I think you are asking about tool, right?
Yes, sir.
Okay, so I think you can take in quite massive amount of extent also, but again, I have not explored the what extent we can select. But generally, when we're using this kind of UBIM, so the extent are majorly those maybe locality level or the neighborhood level, but we are not running that on whole city level, because if we are running that on our own system, that city level, we'll have the computational problem, because you can see within one locality there have been maybe 170 plus building. So
No,
within
whether
this
it has the option or not.
I think it has an option to select a large part, but not maybe certain kind of beyond maybe that.
Can we export it into like DXF for other research purpose?
Yes, as I saw in the initial part, there is an option to export your own input geometries, right? So you can import the DXF files or the basic energy modeling files where the LOD level is 1, right? Just the footprint and the height multiplied. And also you need another file supported with the other geometries what the building properties are being mapped, right?
And the height is we need to give the height for every footprint, or it will take automatically. So
when the normal mapping is done, generally the automatic mapping is done by default 3 meter or else, but you can do the tweaking there also by yourself.
So we need to input the number of floors of the building.
No, see, when you input the geometry import the geometries, so those geometries are majorly by default the floor areas been imported, and a default height is imported, and within the default height, if that height is 3 meter, then maybe it is importing only one floor. Okay, now if you are importing a DXF file where within you have your own subfolders, and within that subfolders you have specified you have 3 floors, 2 floors, and you are being able to map all those data in a systematic way as the city energy analyst needed, then it will import that equally, maybe 2, 3 floors. Okay, so it's completely upon you how you are restructuring that input DXF file. But you need to be very specific. Maybe you cannot do it through basic just DXF mapping. You need to check what kind of DXF or what kind of input format the city energy analyst following the manual, and you need to structure your data or the structure your all those geometries in that particular format itself, because it will do that running of that code, and it will read that data and it will map that into its own platform or environment.
Thank you, sir.
Sir, what type of renewable energy system can we model in this CEA2 in terms of how they are interaction with building loads and microclimate analysis?
Are you talking about this tool, right?
Yeah, but what type of renewable energy? Only solar energy? Yeah, we go to solar, thermal, and other energy can integrate in this tool.
I think there is an option for solar thermal integration also, and the solar, and there is a scope for exploring district cooling strategies also within the network. Yes.
And sir, how can this tool be integrated with GIS data for urban planning software regarding that?
As I was talking about, this tool itself, by itself, I can say it uses OpenStreetMap dataset to import the geometries that have been available. Now, you can not directly use the whole GIS integration within itself, but you can use the GIS to export the building footprints. Maybe you are using the Google OpenStreetMaps or other platforms. So where from you can extract the building footprints. And again, in another maybe DBF or other file formats, you are having the building height details. And again, if you can restructure all this information into the required this tool format, you can use those for your own specified application also, like that. The transition is not smooth, but you can do.
Thank you, sir. Any other participants? If you have any query, please ask.
Sir, what are the other software tools you have mentioned? They are like the same or they have different interface? Like which one is easy to use?
I can say for neighborhood level, and if you are using it in very limited purpose, then this kind of city energy analyst is fine. But late you are doing analysis on a very large scale, as sir was also discussing on that PV cases when the city level assessment they did. So majority of that group or maybe the even W and whoever uses the city BES platform where they connect with LBNL lab, and there they use the supercomputing facilities to run on whole city level assessments. There the single system or the single person cannot run, because a large number of data sets needed to be handled within a computational framework. But for a basic research purpose or basic exploration purpose, city energy analyst can be used in your own system to check the option. As I was last application I was discussing, that supercool material applications to check. Here the city energy analyst you can use. Another software, as I was mentioning, is MIT developed UBEM IO. It is also an offline software, so you need an hard, or I would say very workplace kind of setting, or the very heavy system you need to run UBEM IO. But generally, whenever in a very city level or the large research purposes or the large things are to be considered within city or whole maybe country level assessment are needed to be done, then the city BS and connecting LBNL lab or running it in supercomputing facility is preferred generally.
Thank you, sir.
Any other
I
participants?
just have one question. Sridhar, are you a PhD scholar or faculty?
Sissy there. I'm a
Acha,
master
Sasidhar,
student.
sorry. Master
Master
student
student.
where?
Sir. Gopalan School of Architecture, Bangalore, sir.
Okay. So what is the course about? Is this a sustainability related course or the conventional master's MAC?
No, actually, currently my dissertation is running. The topic is related to energy management.
Energy?
Management or energy.
Management of
Energy
building
management
or
in a building only, sir.
okay. Your question were really nice, so that's why I thought of
Yeah,
asking.
thank you, sir. Thank you very much.
Sir, as far as PB panels are taken into account, how much solar radiations are absorbed and how much are reflected? Number one. And second question related to this one, are these not enhancing the global warming reflected radiations?
No, that's what I discussed, right? Is exactly the answer is given in the PPT. Like only 20% of the heat it is absorbing is converted into the usable energy. Remaining 80% is dissipating to the local environment, right? And because of that, this daytime 1.5 degrees Celsius temperature increase was happening. But night time, when it is radiating back, it is creating a condition where this forced thermal convection is happening. And because of that, the rapid cooling is happening. And because of that, 0.5 degrees Celsius low temperature compared to the base case is happening. So if you will develop a PV, so there are a lot of potential in this particular area, development of a tool or techniques to enhance the efficiency of solar panel. That means it should, whatever it is absorbing should be able to convert into energy. So more and more it will convert into energy, less and less heat it will dissipate to the environment. And second is, whatever heat it is dissipating, is it possible to use those heat for some other purpose, like PV cooling technologies? Right. So if you will cool surface of solar panel, the bottom surface, the efficiency will slightly increase. And since panel is getting heated, whatever the heat is dissipating can be used for cooling of water. Right? And these techniques are already available. But there are some challenges in implementation, and there are some limitation because of which more and more research should go in this direction. Okay. So
Sir, I am talking about the reflected radiations. Are they not contributing to warm up the environment?
reflected radiation. PV is designed to absorb, right? It having very low albedo.
Even though those radiations are reflected, as I observed.
Now, what you have absorbed, it is getting reflected, but not as high as compared to the other environment, right? The purpose is to absorb and then re-radiate.
In
Right.
close in here at Rajasthan, there are the India Asia's largest solar park is there. PV panels park, solar panels are there, and the surrounding environment is very much hot now.
That's what I'm saying. Surrounding environment will be hot because it is absorbing it, right?
It is only due to absorption, not due to the reflection.
It is not mirrored, right? The purpose is to absorb.
Even though
So there are two technologies.
the surfaces are shiny one and they are reflecting.
It is looking shiny. It is looking shiny, but the purpose is that the way it is designed, the color is selected to absorb. So there are two kind of things are there. When I was working for IT Jodhpur project, the two technologies there. One is the solar photovoltaic and one is the solar thermal. So you may be confused between solar thermal, right? The solar thermal, there is a reflector and there is a concentrator, and the concentrator tube having some kind of liquid. Okay. And this reflector, what it is doing, it is reflecting solar radiation towards the concentrator. So in that case, a lot of reflection is happening. Okay. But in case of the conventional PV, the purpose is to absorb energy. Okay. So what you may be saying is a kind of glare you may be seeing because of the shiny surface of panel, but purpose is not to reflect, purpose is to absorb.
Purpose is not to reflect, but the radiations are reflected.
If it will reflect all radiation, then how energy will get generated, right?
Part of radiations are reflected in concentrated part, that is in the
as compared to conventional surface, it will reflect less. Okay. Like cool coating. Cool coating purpose itself is to reflect that.
Thank you, sir. Any other?
Yeah, you can go through some of the study material to understand means how these things happen, or you can refer one of the paper of what I discussed about these nature cities. Solar photovoltaic panel can warm up and cool down cities. There you will get a lot of information, and most of your question will get answered.
So thank you, sir. Firstly, we conclude the session and then further go to the valedictory session. So thank you all for your enthusiastic participation in the today's session, and the discussion provide deep insights into passive cooling strategies, thermal comforts, and the importance of integrating renewable energy into the built environment. and a detailed case study on thermal applications of rooftop solar system illustrated how such installation affect building heat gain and energy performance. Additionally, we explored how urban morphology, such as a building density, height, and space, influences energy demand at the city scales. The session was further enriched by a hand-on exercise using a city energy analyst tools, where participants learn how to simulate and evaluate the building and urban energy performance, assess renewable energy integrations, and analyze the effect of urban from the thermal loads. And together, this approach support informative decision making for sustainable and climate responsive urban development. So thank you again for your active engagement. And as we approach to the conclusion of FDP, so the feedback and test link have already shared with you all participants. So kindly ensure that you fill them out of at your earliest. And also a humble request to Prashant sir. It's honor to us to have to stay with us during this validity session, sir.
Thank you so much, Suman sir.
Wonderful. So continue the validity session. So once again, very good afternoon to all. And as we approach towards the end of this faculty development program on smart building design, ECT for net zero, that is jointly organized by NICT Academy and the Department of Architecture and Planning and Mechanical Engineering, NIT Patna. It is my privilege to formally begin that this valedictory sessions. And over the past several days, we had the opportunity to explore a wide range of topics from energy efficiency, smart controls, renewable energy integration to passive cooling strategies, and sustainable urban housing solutions. These were thought-provoking, technically rich, and truly aligned with the emerging needs of climate responsive to the net zero building environments. So to officially conclude this FDP, I would like to invite my fellow coordinator Subham Meena sir to deliver a concluding remarks of this FDP program. Subham Meena, over to you.
Thank you so much, Ravi sir. As Ravi sir already told a lot about that FDP. So that FDP on smart building design ACT for net zero conducted from 2nd June to 11th June 2025 was a dynamic and insightful initiative hosted by NICT Academy in association with Department of Architecture and Planning and Mechanical Engineering and IT Department. It brought together professionals and educators to explore integrated solution and sustainable energy efficiency and climate responsible built environment. Over the course of this FDP, participant engaged in various in a variety of expert lead sessions that offered both theoretical and depth practical relevance. The key highlights includes net zero energy building design, emphasizing buildings life cycle stage from occupant design to operation and maintenance, with the stakeholder role and responsibilities discussed in detail. CFD based thermal system analysis, where participants undertook hands-on experience to simulate thermal behavior, generate geometric and analyze system performance using ANSYS Fluent. Building integrated photovoltaic and photovoltaic thermal systems, discussing design phase, energy modeling, and the economics and environmental benefit of integrating these systems with architecture. A detailed case study on thermal discomfort in urban slum housing, which highlights challenges in informal settlement and the need for passive climate sensitive design interventions. Non-conventional air conditioning systems, where renewable energy source were explored to reduce dependency on conventional HVAC technology, discussing including type system configuration challenges and comparative advantages. Thermal monitoring and energy efficiency strategies with attention to steady state thermal parameters, passive building features, and the importance of localized climate data. Passive cooling strategy for building and urban areas such as orientation, optimization, shading, evaporative cooling, natural ventilation, and thermal mass application were explored to reduce reliance on active mechanical system. Building energy control systems were addressed through the lens of occupant-centric smart controls. including the application of AI and machine learning to optimizing energy use while ensuring comfort and responsiveness to user behavior. Renewable energy integration session covered method of incorporating solar energy, photovoltaic panels, and energy efficiency applications into building design for greater autonomy and carbon reduction. Indoor air quality was also discussed, emphasizing the importance of ventilation, pollutant control, and a smart monitoring system in ensuring health and comfort in built environment. Climatology and building design strategies, including methods for analyzing site-specific data, solar path assessment, and application of pyramid-like build forms to enhance solar gain and reduce energy load. Participants were also exposed to national and international case studies that demonstrated successful application of energy efficient technologies, climate responsive design elements, and integrated renewable systems such as solar facade and thermal energy storage. This FDP provides a multidisciplinary platform fostering cross-domain knowledge in architecture, mechanical systems, renewable energy, and digital simulation. It empowered participants to rethink conventional building practice and adopt a more responsive, integrated approach to sustainable development. We extend our sincere appreciation to all speakers and participants who actively engage, made this FDP a success. We look forward to continued collaboration and innovation in the field of smart and sustainable building design. Thank you, everyone. And over to you, Ravi, sir.
Thank you, sir, for summarizing the essence of this program. Yes, it is my honor to invite our respected head of the department, Professor Fulena, sir, to say a few words of this occasion.
Thank you very much. The Faculty Development Program on a Smart Building Design, ECT, for Net Zero. I would like to extend my heartfelt congratulations for your active and successful completion program. Over the past days, we have really explored critical themes shaping the future of sustainable architecture and energy efficient system, ranging from net zero principle and passive cooling is technology like this BI and your curiosity, emphasis, and consent has truly elevated the quality and impact of the FDP. This program only broadened academic and but to integrate a sustainable practice into your teaching, research. On behalf of Professor P. Kejan, Director, NIT Patna, who has for conducting this program. I thank you again for your participation and wish you successful journey towards the building a greener and a smarter future. Thank you very much.
Thank you so much, sir, for your continuous guidance and support for this program. Next, it is my honor to invite our esteemed expert, Dr. Prashant Anand, to share a few words on this occasion.
Yeah, first of all, really sorry. I mean, Ravi sir, in your case also means I think you are using Subham laptop, right? And Subham is using another laptop. There also it is written Subham. So I was that time little confused that how Subham changed, his look is changed little bit. Then again he came. Okay, so anyway, that's the fun part, right? I'm really sorry for that, and really thankful to Ravi sir and Subham for conducting this required workshop. I can say this is very timely, because the climate change, its impact on the built environment, the implication what we are facing, like the heat wave, means more and more frequent heat wave is coming. It's very difficult to stay in a room which is on the top floor, right? My name is on the top floor. Without AC, it is very difficult to stay, right? So these things are increasing day by day, right? And this kind of workshop is really required to give more awareness about how to minimize the impact of climate on the built environment, and it's a vice versa kind of thing. If we will try to cool more, the same heat will go outside, and then again we have to cool more, right? So some kind of awareness is required, like the behavioral change, use of energy efficient equipment, using less, consuming less, all those things. So this kind of uh, workshop is required, right? And I believe that means from the day first to this day, so many presentation may have happened, from the design part to the construction part to the facility management part, from the mechanical side, because this is a kind of a multidisciplinary approach. One department cannot solve this problem, right? Every department have to work together, then only this problem can be solved. Although the mechanical department and architecture may have the this kind of priority kind of area in business. Okay, so I'm very thankful, and thank you so much, Fulena sir, for inviting to this wonderful workshop. Okay. As usual, you are helping us a lot. Okay. So my regards to you. Is sir there? Fulena sir?
Yes. Yeah, thank you
Yes,
very much,
yes,
sir.
I am here.
Pranam sir.
खुश रहो भाई.
So thank you very much, sir, for being with us and for your valuable contributions, and to take this opportunity to deliver the vote of thanks. So very good afternoon to everyone. And as we at the end of this faculty development program for smart building design ECT for net zero, held from 2nd of June to 11th June, I take this opportunity to extend my heartfelt gratitude on behalf of the organizing team. First of all, we express our sincere thanks to Professor P.K. Jain, the Director of NIT Patna, for his kind approval and continuous encouragement in hosting this program, and his support for the foundation of the successful execution of this FDP. And we are deeply grateful to the PI, Principal Investigator, and ICT Academy, NIT Patna, for their unwavering support, guidance, and collaboration in organizing these events. Their assistance was instrumental in facilities, expert participation, and ensuring the program reach and quality. And our heartfelt thank of the head of the department, architecture and planning, and mechanical engineering department at Patna for their academic and administrative support throughout this program. And a very special thanks to our convener, Professor Vijay Kumar Das, whose leadership, commitment, and vision shaped this FDP from start to finish, and his constant involvement and direction were the backbone of this initiative. And I also extend my warm appreciation to the coordinator Subham Meena sir for their efforts in managing and ensuring the smooth day-by-day operations. And we are sincerely thanks all the distinguished experts, speakers who shared their valuable insights, research, and experience on diverse aspects of energy efficient and smart building designs. Your knowledge enriched these sessions and significantly contributed to the academic value of this FDP. And last but not least, a big thanks to all of our participants, faculty members, researchers, and professionals from various institutions and disciplines. Your enthusiastic participation, insightful question, and positive engagement made each session vibrant and meaningful. So we hope the learning and connection from this FDP inspire continued efforts and towards sustainable and intelligent building environments. With that, we formally bring this FDP to a close and wishing you all continued success in your academic and professional journey. So thank you, everyone. Any participants who want to say anything, the platform is open for you, or otherwise we close this validity session.
Sir, very much thankful for this program, sir. And importantly, the professors who have presented their papers and their research and all. And very much thankful to the NIT partner staff for widely public advertising about this FTP to reach to all. And thank you, sir. And I would like, I'm very much thankful if you share those PPTs in PPT file type, so I can refer easily. Thank you very much.
Yeah, thank you very much. And one little announcement regarding the certificate and the presentation and all the video. So we already upload all the audio videos on the drive and link already shared with you. In terms of PPT, we ask the experts if they are willing to share with us. So we surely share with you. There is no issue. We share the link of the Google Drives. And in terms of certificates, so the process is going on. Firstly, we share all the data of regarding the registration to the AICT Academy. So first thing we go verify all the registration process. That process will take some time because the financial issues is there. So firstly, so we financial section find out that one, and that we go process. So the certificate will take some time. There is no issue. Or any queries regarding that, please contact us.
So certificate is in digital format only, no?
Yeah, it is in digital format. If anyone required in urgent basis, we provide you from the head, the letter of department letterhead. But the digital soft copy will be shared by EICT Academy. That is particular format by the EICT.
Thank you, sir. Thank you very much.
Thank you, everyone. So we
Thank you, sir. The program was very good, and it was. We think so. In future, we will also join, which will be organized by the NIT Patna. And on the it means lectures on FEM and etc. Its applications. Thank you.